Hello, my name is Bojun Zhao. I'm a graduate student in University at Buffalo, study with Xinru Zhang. My talk is leftward ability and topulation with one-sided branching. I'm very happy to have a learning talk at Tech Topology Conference. At first, we briefly give the background. A foliation in a three-manifold is taught if there is a compact one-manifold transverse to the foliation and intersect every leaf. A group is left-orderable if there is a linear order invariant under the left multiplication of the group. Then we give the motivation. The L-space conjecture proposed by Boyer, Gordon, Watson, and Badger-Hess is that for every closed orientable reducible three-manifold M is a non-L space if and only if pi1M is left-orderable, and if and only if M has meets a countable top foliation. Then we talk about what are known. Auschwitz and Zabel prove that M is a non-L space if M meets a countable top foliation. Gabay proves that M emits a countable top foliation if M has positive first beta number. Boyer, Rolfson, Wist prove that power M is left-orderable if M has positive first beta number. The case of graph manifold is solved by the combined effort of Boyer, Clay, and Hanselman, Rasmussen, Watson. For an irreducible three-manifold with a top foliation, the pullback foliation in the universal cover can be projected to a one-dimensional foliation in the two-plane. This is a theorem of Primera. The leaf space of the pullback foliation is the quadrant space of the universal cover over the pullback foliation, assigned with a quadrant topology. From the theorem of Primera, we can see that the leaf space is a one-manifold and it may not be Hausdorff. The deck transformation induces an action of the fundamental group on the leaf space called the pi1 action. There are three types of top foliation: R-covered, one-sided branching, and two-sided branching. A top foliation is R-covered if the leaf space is homomorphic to the real line, and it has one-sided branching if the leaf space either has exactly one positive end and infinitely many negative ends, or has exactly one negative end and infinitely many positive ends. And the top foliation has two-sided branching if the leaf space has infinitely many positive and negative ends. The two-sided branching is the general case for top foliation, and one-sided branching has an intermediate role between two-sided branching and R-covered. Our main result is that for every closed orientable reducible three-manifold M that emits a top foliation with one-sided branching, pi1M is left-orderable. There are some examples of top foliation with one-sided branching. Means construct infinitely many top foliation with one-sided branching in hyperbolic manifolds. Kagari have some examples that in the finite branch cover over some knots in graph manifolds, there are top foliation with one-sided branching. At last, we briefly talk about another result. A catalysis of the leaf base is a non-Hausdorff point. That is, it is a maximal collection of points which are pairwise non-separated. This picture is a local model of the catalysis. A top foliation has orderable catalysis if every catalysis has a linear order invariant under the stabilizer at this catalysis. Our last result is that for every closed three-manifold that emits a countable top foliation with orderable catalysis, the fundamental group is left-orderable, and we have some further description. The set of ends of the leaf base has a linear order invariant under the pi1 action. There are some examples provided by Finlay. For three-manifold emits a countable anosal flow, the stable and unstable foliations have orderable catalysis. By the previous theorems of Thurston, Calgary Dunfield, Boyer-Hu, and Boyer-Rolfson-Wist, it's known that these three manifolds have left-orderable fundamental group. The left order in our way come from a different way as them. And there are some other examples. Okay, my talk is in, and thanks for the listening, and thanks for the chance given by Tech Topology Conference. Thanks.